The Webb glance is seriously far away. It's picking up light that's been traveling for over 13 billion years. The crazy thing is the universe has been getting bigger the whole time, which means the light has been stretched out. Too, when we look at the most distant stuff, we're basically looking back in time almost to the very beginning, the Big Bang. It's hard to wrap your head around how enormous the universe is, but get this, everything started from this tiny point called a singularity. That's how we think the Big B went down anyway. The James Webb Space Telescope, JWST, has been dropping some knowledge bombs about how the universe was born and how it's grown up. It's kind of mind-blowing. Brian Cox, that famous physicist, even said that what the JWST is finding could totally change the way we understand everything. Let's check out how these space discoveries might shake up what we know. The James Webb Space Telescope, named after a big shot at NASA, is a real feat of engineering. It's better than the Hubble Space Telescope, thanks to a teamwork effort by NASA, some Europeans and Canadians. It uses the latest tech and is designed to zoom in on the universe in amazing detail. Unlike Hubble, the JWST takes super clear pictures of stuff that's really far away. It mainly uses infrared light, which is cool because it can see through space dust and spot things we couldn't see before. It's got this huge 6.5 m mirror made of 18 sections, and it hangs out about 1.5 million kilometers from Earth, going around the Sun with us, so it always has a good view when it looks way out into space. The JWST isn't just seeing light years, it's seeing back in time because of the expanding universe. Light from super objects gets stretched into the infrared. The JWST can pick up this infrared light so scientists can study how stars are born, how galaxies grow, and even peek at the air around planets outside our solar system. One of the newest cool things, the JWST spotted a ton of galaxies way out at the edge of what we can see. This is messing with what we thought we knew, and it's time to rethink some basic ideas about the universe to get how wild this is. Let's take a quick look at space history. The ancient Greeks and Chinese were the first to watch the planets. Then in the 1600s, Newton came up with laws that explained how things move in space. In the 1900s, Edwin Hubble made some huge finds. He figured out that those fuzzy things in the sky were actually whole other galaxies way beyond our Milky Way. He also showed that the universe is getting bigger with galaxies moving away faster the farther out they are. After World War II, the space race started between the Soviets and the US. The Soviets launched Sputnik, the first satellite, and sent Yuri Gagarin into orbit. Then in 1969, the US landed Apollo 11 on the Moon. Moving ahead to 1990, the Hubble Space Telescope gave us great pictures and new info about the universe. From those early skywatchers to the JWST, it's amazing how far we've come in understanding space. The Hubble Space Telescope HST, for instance, gave us the famous Pillars of Creation picture in the Eagle Nebula, showing a star nursery. It also took the Hubble Deep Field image, which showed thousands of galaxies in what looked like an empty part of space. The HST even checked out the air around planets outside our solar system, finding water and stuff that might mean there's a chance for life. And by watching a supernova SN 1987A, it helped us understand how big stars live and die. The James Webb Space Telescope is building on all of that, using better tech and what we learned from Hubble. One of our best guesses about where the universe comes from is called the Big Bang Theory. It says that about 13.8 billion years ago, the universe was super hot and dense. Then it quickly got bigger, creating matter, energy, and all the forces we know. As it expanded, it cooled down, and stuff like atoms, stars, and galaxies started to form. The Big Bang Theory also does a Good job of explaining the cosmic microwave background radiation light and the amount of light elements we see even. Though a lot of people believe it, the Big Bang Theory had its doubters at first. Some people suggested other ideas, like the steady-state theory, which said the universe always looked the same, but over time more stuff was found that supported the Big Bang. One big piece of proof was the cosmic microwave background radiation light, which scientists detected in 1965 space missions, and tech advancements kept backing up the theory. Now we have the James Webb Space Telescope. It's got really good infrared instruments, so it can see through all the space dust. It's picking up light from the oldest stuff in the universe, like the first things that formed right after the Big Bang. Since it uses infrared light, it can check out where stars are born and how they're made, even if they're hidden behind clouds of dust. Infrared light is good because it has longer waves than visible light, so it can get through the dust, and the telescope can spot cooler stuff that only gives off infrared light, like planets outside our solar system and really far away galaxies. When things in space move away from us, their light waves get stretched out, which makes them look redder. This is called redshift. The JWST can spot this redshifted light, so you can see things from way back in the early universe. I can also see cool space events like black holes merging or new stars being born because they give off a lot of infrared light. The JWST works with other telescopes like the Hubble. By seeing different kinds of light, it can see more and go further, so we get a better picture of how the universe has changed over time. It's basically given us a time machine to look back at the beginning of everything. Just recently it found something that might make us change the whole Big Bang Theory. It spotted a bunch of huge galaxies way out at the edge of the universe. These galaxies were around just a few 100 million years after the Big Bang. The head-scratching part is that we don't know how they got so big so fast. This discovery could change how we think galaxies formed in the first place. Looking at these early galaxies is super important if we want to understand where we all came from. With a JWST, we can learn how galaxies, stars, and planets appeared and changed over billions of years. That also helps us answer bigger questions about what the universe is made of, how it's shaped, and what forces control it. The Hubble was awesome for its time, but it couldn't see the early universe very well. It couldn't get through the space dust to see the infrared light from old galaxies. That's why the James Webb Space Telescope is such a big deal. It can see things that formed just after the Big Bang. It is also giving us awesome details and helping us understand how the universe grew up. The first stuff we're seeing from the JWST is creating some conversation about our ideas about the universe. The new data is making cosmologists think again about how things began and how everything is structured. There are a lot more galaxies in the early universe than we thought. This means that galaxies might have grown faster than we expected. Plus, some of the galaxies look older than they should. These observations are making scientists wonder if we have the right ideas about how things work in space. In simple terms, the telescope's observations have prompted scientists to rethink and improve our models of the universe. Right now, we know that we need to do more looking around to get these surprises into our understanding of the universe. Initial observations often provide exciting glimpses into the universe, but in-depth investigations sometimes reveal differences. For example, early observations may show specific properties or arrangements within distant galaxies that, upon closer examination, reveal fluctuations in their composition, structure, or evolutionary pathways. One thing scientists do to understand space stuff is called spectroscopy. It helps them figure out what things are made of and where they came from the JWST often finds that the first quick look doesn't tell the whole story. For example, it found some galaxies that seemed to be pretty simple at first, but when scientists looked closer they found heavier stuff that they didn't expect to see in the early universe. This is making them rethink how the universe was put together at the beginning. The James Webb Space Telescope keeps showing us new stuff and changing how we think about space. One cool thing it does is study planets outside our solar system. By looking at the air around these planets, it can spot chemicals such as water and methane that helps us figure out if there might be life on other planets. The JWST is also showing us how stars are born. Lots of young stars are hidden behind clouds of dust, but the JWST can see through the dust and give us cool pics. This is helping us understand how stars like our sun come into the world. Plus, the JWST is peeing into the middle of galaxies where there are usually big black holes. It is helping us learn how these black holes grow and how they affect the galaxies around them. All these findings are making us ask new questions as the JWST looks further back in time. It is finding things that don't fit with our current theories. That is pushing scientists to come up with new ideas and ways of understanding the universe. So the JWST discoveries are not just pushing the boundaries of what we know, they are helping to reshape the fundamental principles of how we view the universe itself. The light captured by the James Webb Space Telescope JWST has been traveling for over 13 billion years from almost the beginning of the universe. This has revealed mysteries about the universe's birth, and according to physicist Brian Cox, could change our whole understanding of it. The JWST is a huge step up from the Hubble Space Telescope, made through teamwork by NASA, the European Space Agency, and the Canadian Space Agency. It uses the latest tech to see the universe in great detail. Unlike Hubble, JWST takes clear pictures of faraway galaxies by focusing on infrared light, allowing it to see past space dust and spot hidden objects using its giant 6.5-meter mirror, and orbits the Sun with Earth about 1.5 million kilometers away, giving a steady view of space. The JWST uses infrared to study galaxies and events from billions of years ago. Light from these galaxies stretches as the universe expands, moving into the infrared range. The JWST can spot this infrared light, letting experts study how stars are born, how galaxies grow, and what exoplanet atmospheres are like. A recent find includes huge groups of galaxies at the edge of what we can see, challenging how we thought things began. Looking back, ancient groups understood planet movements in the 17th century. Newton's rules gave a plan for space travel. Edwin Hubble found that other nebulae were basically isolated worlds, long way from our galaxy, changing how big we thought the universe was. Hubble's law said that farther galaxies move away faster, and proof to the universe's growth. The Soviet Union Sputnik launch in 1957 and Gagarin's trip, plus the 1969 Apollo 11 moon landing, became big steps in the space race. In 1990, the Hubble Space Telescope gave amazing views of space. Hubble's famous pillars of creation showed starbirth in the Eagle Nebula. The Hubble Deep Field caught lots of galaxies in empty space. HST also found elements like water in exoplanet atmospheres, hinting at life beyond Earth. These accomplishments made Hubble a base of modern cosmology. Its replacement, the James Webb Space Telescope, was created to improve on these advancements. This growth is based on the Big Bang Theory, which says the universe began as a hot dense spot about 13.8 billion years ago, quickly growing and making matter, energy, and forces. The universe cooled as it grew, making atoms, stars, and galaxies. The JWST uses infrared tools to see past space dust, and mainly captures the oldest light in the universe. Its infrared view is ideal for studying exoplanets, stars forming, and distant galaxies as objects move away. Their light stretches into longer wavelengths known as redshift. Being skilled at infrared light is how the JWST can detect this redshift, capturing light from the early universe. This helps. It has a window into the earlier phases of space. It recently found galaxies at the edge of the visible universe that existed shortly after the Big Bang. During the cosmic dawn, Hubble couldn't see past space dust to spot the infrared light from old galaxies. The James Webb Space Telescope is designed for this, using its infrared view to see galaxies from just a few 100 million years after the Big Bang. Clearly understanding the universe's history, results from JWST have caused cosmologists to rethink how we understand universe, because there are a larger amount of galaxies in the early universe than models showed, showing quicker development. Basically, scientists are revising our understanding of the universe. Deeper examinations might show how early observations may reveal galaxy features. Spectroscopy is a technique that analyzes light emitted by stars to know its substance, temperature, and movement, enhancing our grasp of its beginning. JWST found heavier elements in early galaxies that went against past thoughts about the early universe. The James Webb Space Telescope keeps redefining space by exposing undiscovered areas. It studies exoplanet atmospheres. It finds water and elements, which reveals insights into the possibility of habitability. It also looks at how stars are formed in black holes, which helps our understanding of how galaxies and related black holes grow together, impacting each other's development. Further, it is making the models to have a need to grow and become more refined.